So the next two videos, I think the next two, laws of exponents, I'm going to present together because they really go hand in hand, which is power to a power and also quotient to a power. So let's look at rule number 5. When we have a power to a power, to find a power of a power when there's the same base, you're going to multiply the exponents. And when you have this is pretty straightforward. You're just distributing this one in. So a to the m to the n is a to the m times n. Or you're going to distribute this into both. Remember that the exponent here is 1, so a to the 1 times n and b to the 1 times m is equal to a to the m, b to the m. Let's try a couple examples and see if it makes more sense. I see that I have a power to a power. I'm going to raise everything in there to the third power. And you can also keep in mind, if you go back and think about how when we had x cubed is equal to x times x times x, now we have n cubed, right? We have n squared cubed, right? So we have n squared times n squared times n squared. We have 3 of these. So how many n's do we have total? Now we have 1, 2, 3, 4, 5, 6. So n squared cubed is equal to n to the 2 times 3, which is n to the 6th. And if you go down here and count, you'll see 1, 2, 3, 4, 5, 6 n's. Let's try the next one. I'm going to cube everything in these parentheses. I have x to what power? Well, this is x to the 1, and we're going to multiply that times 3 times y to the 2 times 3. 1 times 3 is 3, x cubed, and 2 times 3 is 6. So y to the 6th, and this is our answer. And let's check this one in Desmos. So we have one example checked for us. And I can't use x and y in Desmos when I'm checking exponents. So I've substituted in m and n. You can use any two that aren't x, y, or e. So we're going to add sliders to all, set the sliders to anything other than 1. Let's try 2 and 3. And we found this to be equivalent to m cubed, n to the 6th. These numbers should match, and they do. So we've evaluated that correctly. And here's my favorite one again. But we can distribute this 0 in to everything in here. 3, 4, you have a to the 1 times 0. You have b to the 1 times 0. C to the 1 times 0. D to the 1 times 0. And anything times 0 is 0. So a to the 0, b to the 0, c to the 0, d to the 0. What is anything to the 0 power? Well, it's 1. 1 times 1 times 1 times 1 equals 1. And that's your answer for that one. Let's go ahead and look at quotient. Power to a quotient. So to find the power of a quotient, it's going to be very similar. We're just distributing the power in to each term, the same thing that we did before, because multiplication and division are kind of the same thing, right? They're opposite. They're inverse operations. So the same thing that we did with a product, we can also do with a quotient. So here we have x over y cubed. We're going to raise everything in there to the third power. So x to the 1 times 3 over y to the 1 times 3 equals x cubed over y cubed. And that's your answer. What about here? We have a 1 on top. Does it matter? What is 1 to the 4th power? We have 1 to the 4th power over x to the 2 times 4. On the top, we'll have 1. On the bottom, x to the 8th. Let's check that one. This one we can even check using a cool graph. This is when because x is defined in Desmos, it's going to start creating a graph. Now, if these two are equivalent, then they're graphs. One should overlay the other. And sure enough, does the blue cover the red? Yes. So we've evaluated that one correctly. So we have one final one. We're going to reach for the stars here. I'm going to distribute this 2 into everything inside these parentheses. A to the 2 times 2, B to the 3 times 2, over C to the 4 times 2, equals A to the 4th, B to the 6th, over C to the 8th. And I can double check this one in Desmos, so I will. We're going to add sliders to all. Set these to anything other than 1, 3, 4, 5. They should be equivalent, and in fact they are. I hope this video was helpful. Thank you so much for watching.